So 1.7 is on linear inequalities and absolute value inequalities. So solving an inequality is the process of finding the set of numbers that make the inequality a true statement. These numbers are called solutions of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. We have two notations to describe a solution set of an inequality. We have set builder and we have interval notation. First, let's talk about interval notation. Some sets of real numbers can be represented by using interval notation. So let's suppose that a and b are two real numbers and that a is less than b. So interval notation, the open interval, parenthesis a comma b, represents the set of real numbers between but not including a and b. And so we can write this with two parentheses, a comma b, is equal to, we have curly brackets, x, such that a is less than x, which is less than b. The closed interval, which has closed brackets, represents the set of real numbers between and including a and b. So closed bracket, a comma b is equal to the set x such that a is less than or equal to x, which is less than or equal to b. So the difference between these two notations is that the parentheses includes less than but not equal to, and these square brackets have less than or equal to in both pieces. The infinite interval from a to infinity represents a set of real numbers that are greater than a. So we can write this as any number greater than a, so x such that x is greater than a. And we always use parentheses when talking about infinity because it's just a notation, it's not actually a number. And the other infinite interval from negative infinity up to b with a closed bracket represents the set of real numbers that are less than or equal to b. So the set of all x such that x is less than or equal to b. So closed brackets mean that you have that equal sign on your inequality symbol, and parentheses means that you do not. And you always use parentheses when talking about positive infinity or negative infinity. So let's express each interval in set builder notation and graph. And so set builder notation is that notation with the curly braces we just saw. So it always starts with a curly brace and x, and we put a vertical bar. We start with the number that's to the left, or the negative, more negative number, so -1. And because it has a parenthesis, that means it's strictly less than. We put our x in between, and we have 4 with a square bracket, which means this is less than or equal to 4. And then you close your brace. And all that means is that on -1, we'll draw a parenthesis, and on +4, we will draw a square bracket. And so what this means is x is in between these two boundaries. So in between -1 and +4, including +4 but not including -1. Now let's pause the video and you try 1b. Alright, so to write this in set builder notation, we always have our curly bracket with an x and a straight line, and this is from -4 to infinity. So what this means is that any number greater than -4 is in my solution set. So that means that x just has to be strictly greater than -4 since we have a open parenthesis. So we just want to come down to -4 and we're going to put an open parenthesis on it. And since this includes every number bigger than -4, we're just going to draw our green line across the entire thing with an arrow pointing in the positive direction. Now let's talk about intersections and unions of intervals. So recall that A intersect B, or it looks like a cap, is the set of elements common to both set A and set B. So intersection means that they have elements in common. So it's like the intersection of streets. It's only the piece that each street has in common. So on the other hand, A union B, which looks like a U, is the set of elements in set A or in set B. So this is like the union of two people in a marriage. So both people bring their personalities and their lives together, and so marriage has both pieces of both people. So finding intersections and unions of two intervals, you want to graph each interval on a number line. And to find the intersection, we take the portion of the number line that the two graphs have in common. And if you want to find the union, you take the portion of the number line representing the total collection of numbers in the two graphs. So let's use the graphs to find each set. We have 1, 4 with parentheses, intersect 2, 8 with square brackets. So I'm going to use pink to represent 1, 4. So we have parentheses on 1 and on 4, and we just have our line in between. And I'm going to use blue to represent the 2, 8. Let's just extend this out here a little bit. We've got 6, 7, and 8. Alright, so going back, I have my square bracket on 8, I have a square bracket on 2, and then it's got its line in between our two endpoints. So because this is an intersection, we want to see where these two graphs intersect or what pieces they have in common. So we want to look for pink and blue on the graph. So let's just look. I've got some pink and blue going on right in this region. And so what you see is what you write, even including the symbols. So because 2 has a bracket on it, we're going to have bracket 2, comma, all the way up until 4, which has a parenthesis on it, and that is your final answer. Now go ahead and pause the video and try 2B for yourself. Alright, so let's do the exact same thing, except now we're looking at the union. So let's redraw this graph a little bit. I'm going to extend my graph out just a tad, so I can take an account for 6, 7, and 8. Again, I'm going to use pink for 1, 4, and I'm going to use blue for 2 up until 8. Now because this is the union, you want to take every piece that has a color on it, whether it is pink or blue. So the most left point and symbol is a parenthesis on the 1, and the rightmost symbol is a bracket on the 8. So my union is going to be 1, comma 8. The 1 has a parenthesis, and the 8 has a bracket. And that is your final answer. Now let's talk about solving linear inequalities in one variable. So a linear inequality in x can be written in one of the following forms. Ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, or ax plus b is greater than or equal to 0 as long as a is not equal to 0. So inequalities with the same solution set are said to be equivalent. In general, when we multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol is reversed. And this cannot be stressed enough. So if you multiply or divide both sides of an inequality by a negative number, you must flip the sign. If you forget to do this, you will end up with the wrong answer. So this is very, very important. So let's go ahead and use this information to solve and graph the solution set on a number line. All right, so we've got 3 minus 2x is less than or equal to 11. And we want to get x by itself on one side. So let's subtract 3 from both sides. I have negative 2x is less than or equal to 8. And I want to divide both sides by negative 2. But whenever I divide by a negative number, I have to flip my sign. So my negatives 2 cancel. I'm left with x is now greater than or equal to negative 4. And I just want to write this on my number line. So because it's greater than or equal to negative 4, I'm going to put a bracket on negative 4. And any number greater than it is an answer to my equation. So we're just going to shade to the right-hand side up until positive infinity. And that's my final answer. If we were to write this in interval and set builder notation, interval notation would be bracket negative 4 till positive infinity with a parenthesis, and set builder has my curly braces x such that x is greater than or equal to negative 4. Now go ahead and pause the video and try 3B for yourself. Okay, so what we want to do is we want to isolate the x on one side. So I am going to add 2x to both sides. So I have negative 4 is greater than 3x plus 5. Let's try to get this x by itself. So we're going to subtract 5 from both sides. We have that negative 9 is greater than 3x. And dividing by 3, we have that negative 3 is less than x. If I want to write this in the opposite order, all I have to do is flip sides and flip the sign. So let's go ahead and do that. So this is the same thing as x is less than negative 3. So let's go ahead and write this in interval notation first. So any number less than negative 3 is a solution to my equation. So this means going all the way down to negative infinity. So negative infinity all the way up to negative 3, and both of these have parentheses. And in set builder, we have our curly braces x such that x is less than -3. Now we just want to come down and graph our solution set. So -3, we have our parenthesis, and any number less than this is an answer, so going down to -infinity, our graph will look like so. Alright, go ahead and pause the video and try part C for yourself. Okay, so first thing that I want to do is I want to multiply by the least common denominator to get rid of the fractions. So our least common denominator between a 4 and a 3 is 12. We want to multiply each piece by 12. So I've got 12 times x plus 3 over 4 is greater than or equal to 12 times x minus 2 over 3 plus 12 times 1/4. So when we do this, we end up canceling out the fractions. 12 and 4, you have a 1 on the bottom and a 3 on the top. Between 12 and 3, you have a 4 on the top and a 1 on the bottom. And between 12 and 4, you have a 3 on the top and a 1 on the bottom. So my new equation looks like 3 times x plus 3 is greater than or equal to 4 times x minus 2 plus 3 times 1. This looks so much better than what we started with. So let's just simplify a little bit. Let's distribute the 3. We're also going to distribute the 4, and 3 times 1 is just 3. So we've got 3x plus 9 is greater than or equal to 4x minus 8 plus 3. Well, let's combine like terms here. I've got a -8 and a plus 3. So 3x plus 9 is greater than or equal to 4x minus 5. We want to get x by itself on one side. So I'm going to subtract 4x from both sides. We have -x plus 9 is greater than or equal to -5. Let's subtract 9 from both sides. And so we get that -x is greater than or equal to -14. But I don't want -x, I want positive x. So we're going to divide both sides by -1. But when I divide by a negative number, I have to flip the sign. So what we really have is x is less than or equal to +14. Now let's go ahead and write this in interval notation. So any number less than 14, even including 14, is an answer. So from -infinity to +14. And in set builder notation, we have curly braces x such that x is less than or equal to 14. Now let's go ahead and come all the way down. This is going to go on for a long bit here. And I'm just going to write a 14 so that you get the idea. And so we're going to have a bracket on 14. And anything less than it is a solution. All the way down to -infinity. So inequalities with unusual solution sets. So not every inequality is going to have a solution set like the ones we just did. Some will have no solution, so its solution set is the empty set and it looks like a 0 with a line through it. If you attempt to solve an inequality that has no solution, you will eliminate the variable and obtain a false statement such as 0 is greater than 1. On the other hand, some inequalities are true for all real numbers. So if you attempt to solve an inequality that is true for all real numbers, you will again eliminate the variable, but you obtain a true statement such as 0 is less than 1. So in both of these instances, the variables eliminate completely. If it's no solution, you get a false statement that makes no sense. And if it's all real numbers, then you get a true statement that does make sense, like 0 is less than 1. So let's go ahead and attempt this for 4a. We're going to solve these the exact same way. So let's distribute the 2. So I have 2x plus 8 is greater than 2x plus 3. Well, subtracting 2x from both sides, they end up canceling and we just get 8 is greater than 3. Now, is this a true statement? I sure hope so. So this means that our solution set is all real numbers. And we can write it as so. So it looks like an R with 2 lines. You can also write it in set builder notation. We have our curly bracket, and then we have x, such that x is a real number. Or you can write this in interval notation, and that's from negative infinity to positive infinity. And so all 3 of these, or I guess 4 of these, are correct answers. So go ahead and pause the video and attempt 4b for yourself. Alright, so x plus 7 is less than or equal to x minus 2. So let's subtract x from both sides. Well, this means that I have 7 is less than or equal to negative 2. Now, is that a true statement? This is definitely not a true statement. This is a false statement. And since this is false, that means that the answer is no solution. Or we can write this as that 0 with the slash through it. What about compound inequalities? So this is when 2 inequalities that have been combined into one inequality. We omit the word and it allows us to solve both inequalities at once. So by performing each operation on all 3 parts, the goal is to isolate x in the middle. So let's go ahead and try this with example number 5. I've got negative 3 is less than 2x plus 1, which is less than or equal to 3. So I want to get this x completely by itself in the middle. So the first thing we can do is we can subtract 1 from all sides. So I have negative 4 is less than 2x, which is less than or equal to 2. Well, I still have 2x in the middle when I want just x, so we're going to divide each piece by 2. So I end up with negative 2 is less than x, which is less than or equal to 1. And so let's go ahead and write this in set builder and interval notation. Well, because negative 2 is strictly less than, that means it gets a parenthesis. and 1 is less than or equal to, so it becomes a square bracket. We can also write this in set builder. We got our curly brace, and then we have -2 is less than x, which is less than or equal to 1. And let's go ahead and put this on the number line. So at -2, we've got our parenthesis, and at 1, we have our brace. And it's any number that's in between these two endpoints. Right, let's solve some inequalities with absolute values. So if u is an algebraic expression and c is a positive number, the solutions of the absolute value of u is less than c are the numbers that satisfy -c is less than u, which is less than c. The solutions of the absolute value of u is greater than c are the numbers that satisfy u is less than -c or u is greater than c. Same rules apply if it's less than or equal to or greater than or equal to. So there's a little trick to remember. So when we solved absolute values before, we had to set them or isolate them by themselves, and then we used the plus and minus of the number that was on the opposite side. We're still kind of doing that, but one is giving me a compound inequality and the other one is not. So the way to help us remember is if it's less than, that means it's less than. And is a compound inequality. If it's greater than, then we have that this is great or. So if it's greater, you know that this has to be an or equation. And if it's less than, you know that it has to be a compound inequality. So let's go ahead and use this notation for solving the following equation. So we want to make sure that the absolute value is completely isolated. That still hasn't changed from before. So let's subtract 7 from both sides. So we have -2 times the absolute value of 3x plus 5 is greater than or equal to -20. We still don't have that absolute value completely isolated, so let's divide by -2. But when we divide by negative, we have to flip the sign. So we have the absolute value of 3x plus 5 is less than or equal to 10. And so what looked to be a greater problem is now a less than problem, and it's a compound inequality. So the way we set this up is we put the 3x plus 5 in the middle, or the inside of our absolute value. We still have that this is less than or equal to +10, but on the other side, we're just going to put a -10 and a less than or equal to sign. And then we just solve this by getting the x in the middle by itself. So we are going to subtract 5 from both sides. So we have -15 is less than or equal to 3x, which is less than or equal to 5. Now dividing by 3, we end up with -5 is less than or equal to x, which is less than or equal to 5/3. So let's go ahead and write this in interval and set builder notation. So in interval notation, this is bracket -5, comma, 5/3 with another bracket. In set builder, we have x such that -5 is less than or equal to x which is less than or equal to 5/3. Now let's go ahead and put this on the number line. Well, -5 is pretty easy. And we have a square bracket. And 5/3 is about 1 2/3. So it's almost at 2, but not completely. So we're just going to put it doesn't have to be perfect, just close. And it's any number that's in between these two boundary points. So go ahead and pause the video and try 6B for yourself. Okay. So first thing is you want to have that absolute value on the left-hand side of the inequality symbol. So let's flip the sides and flip the sign. So we have the absolute value of 5 minus 2x is greater than 7. So again, what looked to be a less than problem is now a greater problem. So we want to split this into two different equations with an or in between. So we have 5 minus 2x is greater than 7, or we have 5 minus 2x is less than -7. And we just want to solve these. So let's subtract 5 from both sides. So we have -2x is greater than 2, or we have -2x is less than -12. So dividing by -2, we have to remember to flip the sign when we divide by a negative. So we have x is less than -1, or we have x is greater than +6. And so the way we write an or, this is a union of sets. And so let's go ahead and write this. If x is less than -1, that means anything less than all the way to -infinity is an answer. So we have -infinity to -1. Or, and anything greater than 6 up to +infinity is an answer. And then the only thing we want to do is we want to replace the or with a union symbol. So you can write this as -infinity to -1 union 6 to infinity. We can also write this in set builder notation. And so we just write x such that x is less than -1, or x is greater than 6. So let's go ahead and graph this. I'm going to come down and extend my number line just a little bit. So let's go ahead and graph x is less than -1. So this means that anything less than it is going to be a solution. Now anything greater than 6, or x is greater than 6, is also a solution. So what this means is any of the colored areas, whether it's the pink or the red, is a solution to our equation.